Hi, my name is Denise Falcone, and in this video I will present you the poster which I prepared for the ESDR 2017 meeting in Salzburg. And my poster is entitled Effect of Blue Light on Inflammation and Skin Barrier Recovery Following Acute Perturbation. And this study was performed at the Dermatology Department of the Radboud University Medical Center in Nijmegen, the Netherlands, in collaboration with Philips Research Eindhoven. So first of all, why blue light? Because the therapeutic effects of UV-free visible and near-infrared optical radiation relying on the non-thermal photochemical and photobiological interactions have been the object of increasing attention in recent years. And among all the wavelengths, there is growing evidence on the positive effects of blue light at 453 nanometers in the treatment of inflammatory skin diseases such as psoriasis vulgaris and atopic dermatitis. But at the same time, while many studies have focused on diseased skin, data on the effects of blue light on acutely perturbed but otherwise healthy skin are still scarce. So what we did in our study was to investigate the biological effects of blue light at 453 nanometers on the inflammation and skin barrier recovery following acute perturbation of healthy human skin. And the irradiation parameters that we used was fluence at 18 joule per square centimeters and a treatment time of 30 minutes. Then, as a secondary aim, we also wanted to investigate whether irradiation in continuous mode or in pulse mode had a differential effects on the outcome. So we included two groups of volunteers. In one, we irradiated in continuous mode, and the irradiance was 10 milliwatts per centimeter square. And in the second group, the pulse group, we used the average irradiance, which was also 10 milliwatts per square centimeters, but we used a peak irradiance of 200 milliwatts per square centimeter. So how did we perform the study? So we performed acute skin perturbation on the volar forearm of 22 healthy volunteers, and we used to establish in vivo skin models. The first one was tape stripping, which consists in the repetitive application of adhesive tape to the skin in order to remove the stratum corneum completely. And we could assess the removal of the stratum corneum by the appearance of red skin and glistening skin, as you can see in the picture on the right. And the second in vivo model was histamine ionophoresis. Ionophoresis is a technique which uses a small amplified electric current to facilitate the penetration of charged molecules into the skin. And here in the picture you can see the characteristic wheel and flare reaction elicited by histamine in the skin. So what about the study protocol? The study protocol was performed over 2 consecutive weeks, and in each week we had 3 visits. So on the first visit of each week, we performed acute perturbation with tape stripping and histamine ionophoresis. And in the case of the irradiation week, the perturbation was immediately followed by irradiation with a blue light. And then afterwards, we evaluated skin reactions in both weeks in the same way, using non-invasive biophysical measurements, which consisted, you can see the pictures here at the bottom, in transmitted water loss, diffuse reflectance spectroscopy, from which we could get the LAB values, and we could also calculate the individual topology angle, or eta. And then we also measure the biomarkers at the surface of the skin by means of a transdermal analysis tape or TAP. And also we measured refractance confocal microscopy to get an idea of the morphology of the skin. So you can see that on the first visit we measured the diffuse reflectance spectroscopy at 30 minutes and 1 hour after histamine ionophoresis, and at 1 hour after tape stripping. And at the same time point after tape stripping, we measured also transepidermal water loss. And then for the following visits, visit 2 and visit 3, which were performed at 24 hours and 72 hours after the first visit, we only measured on the tape stripping spot because the skin reactions to histamine faded quite quickly, so we could not see anything more on the skin at later time points. So visit 2 and visit 3, we still measure transmitted water loss and diffuse reflectance spectroscopy. And at visit 2, we also added measurement of protein biomarkers with TAP. And at 72 hours, we measured RCM. And baseline measurements were always performed on the forearm contralateral to the one where acute perturbation was applied. And of note, in the irradiation week, we performed tape stripping, an additional tape stripping in the forearm which was not irradiated, and this was used as an additional control. So, after all, what did we obtain in this study? So, if we skip to the results page, for the histaminosupphoresis, you can see in the table we reported the parameters which we obtained with DRS, and we can see that at 30 minutes there was a lower L star, B star, and eta values in the irradiation week compared to the control week. And for that, we could conclude that there was an increased blood concentration in the spot which was previously irradiated with a blue light. But on the other hand, this effect was lost at 60 minutes after ionophoresis, because in that time point we could not see any difference anymore. So, what about tape stripping? In this graph, you can see the increase in transpidal water loss with respect to baseline at each time point of the study. The blue bars represent the measurements performed after irradiation with blue light, and the white bars are the control measurements. So, in this case, tape stripping was not followed by irradiation. So, you can see that at 24 hours, there was higher delta transpidal water loss in the irradiation spot, and from which we could conclude that the barrier recovery was slightly delayed in this case. But we did not see differences in other time points. And also when we consider the difference between the tape stripping spot irradiated with blue light and the tape stripping spot, the control performed in the irradiation week, we could not see any difference in that case. So could that have been mediated by a systemic effect? That remains to be investigated in further studies. Also, in the tape stripping experiments, quite some interesting results emerged for the interleukin-1 alpha measured with TAP. So you can see here in the graph, the black bar represents the measurement at baseline on intact skin. The white bar again is the control measured at 24 hours after tape stripping without irradiation, and the blue bar is the measurement at 24 hours after tape stripping and irradiation. So you can see that while there was upregulation of interleukin-1 alpha between the control and the baseline, we could not see any the upregulation in the 24 hours after tape stripping in the irradiated spot was not significant compared to the baseline. And also we could not see any significant difference between the control and the irradiated tape stripping spot. And finally, for tape stripping, here in this table you can see that as for histaminosupphoresis, we reported the values obtained with diffuse reflectance spectroscopy, and you can see that at each time point of the study there was a higher B star value and lower eta value, and these differ between the irradiation and control week, and this difference was significant at 72 hours. So we could conclude that there was a slight increase in pigmentation after irradiation with blue light compared to the control week. And of note, very similar results were obtained when we compared the irradiated tape strip spot with the non-irradiated tape strip spot performed in the same week. And as last, the second objective of our study was to see whether there was a significant difference between irradiating in a pulsed or continuous mode. And we always observed higher biological effects in the pulsed irradiated group compared to the continuously irradiated group, but we could never see a statistical, the difference was never statistically different. So at the end, we concluded that a single irradiation with blue light at 453 nanometers exerts biological effects on acutely perturbed healthy human skin. And our results suggest a conditioning effect of blue light on skin barrier formation, and this effect is possibly mediated by epidermal cytokines. And these findings could be possibly linked to the positive outcomes of the blue light at 453 nanometers, which have been observed in previous studies on atopic dermatitis and psoriasis. And then, according to our results, it will be important to investigate also the blood plasma biomarkers, and not only sampling biomarkers at the local level, in order to infer possible systemic effects elicited by blue light. And finally, the irradiation in pulse mode with high peak irradiance seems to elicit stronger biological effects than irradiation in continuous mode, as was reported also by previous studies, but the mechanistic pathways remains to be unraveled. So I would like to acknowledge the other authors of the study, who helped me to perform the study, and all the volunteers who took part in this study. And thank you for watching this video.